All right, greetings. I'm going to demonstrate how one can clone a repo in Visual Studio Code and operate with the CMake targets that are prescribed in my projects using the CMake tools plugin or extension rather provided by Microsoft for Visual Studio Code. So this is just a dummy repo that I've created. It has nothing to do with class. In fact, it's the template that I use to create your lab assignments with. So I'm just going to clone this. So as usual, I'll just go ahead and grab the URL. I have my SSH credentials configured for this cloning operation. And so after grabbing the URL, I'm just going to switch over to Visual Studio Code. Now, just a word on some extensions I have installed in here. I did install something called the Git lens, which is helping to facilitate some of these operations, but it may come straight out of the box with the source control that comes with Visual Studio anyways. It's Visual Studio Code. And by the way, if I keep saying Visual Studio, that's a slip up. I really mean Visual Studio Code. So if we go to View, I can bring up the command palette, and then I can choose Git clone. You can see I've done this recently. So Git clone, and then I need to specify the URL. So I'll just paste what I have here, and then it's going to ask me where I want to put it. I've opened up Visual Studio Code here from within my Ubuntu WSL environment. So I'm actually looking at the file system for my Ubuntu system, and I've created a place that I wanted to hold these things called VS Code projects. It's just something, you probably have your own CSC 232 directory or whatever you want to do here. I just created this just for this demo. So I click OK, and it's cloning. Now that it's cloned, it's asking me whether I want to open the clone directory, and I do. And so Visual Studio Code is reopening. It's opening the remote session to the WSL system underneath. And here we are. Now on top of this, it should recognize that this is a CMake tools project. And so it's starting to automatically configure the project based on the CMake list text file. This is essentially what CLion is doing, what we see CLion doing when we open up the projects in CLion. And once this has gone through and finished up, we can take a look at some of the things that are afforded to us by the CMake Tools extension. Before I do that, though, I do want to make a couple of quick changes here, just to show you how I can use some of the features from the Git lens extension and or source control extensions available here. I'm on the master branch, so I want to create a new branch. So I just clicked on the branch, and I want to create a new branch. Typically, we create a develop branch in our projects. And there we go. Now I'm going to make a small change to my CMake list text file. This is an issue that's creeped up this semester that I'm not sure why it's doing this. Might have to do with the newer versions of the compiler. But I want to get rid of these pedantic switches here. And I have a dog barking in the background. Sorry about that. And that's reloading now that I've made some changes. Okay, very good. Now, the CMake project reloaded. That's all well and good. I want to go one step further now and actually commit this change. So here I have the source control extension, and it shows me the files that have changed. And it shows this M says, hey, this has been modified. So it's not staged yet for committing, though. Remember, staging a file is involved using that git add command will That's what this plus sign will do for me. It will stage our changes. Okay, the changes are staged. And now I can add a commit message. Remove pedantic flag. And then control enter to make that commit. I can also bring up my command palette and do a git push. It tells me that the upstream doesn't have a develop branch. Do I still want to publish this? And I do. And so it's doing its thing. And now it looks like it's been published. In fact, we can check that now. Looking here, we see, oh yes, something has happened. Develop had recent pushes less than a minute ago. I can compare and pull request. Demo session. I'll name this pull request. And there we go. I've got a pull request. And now, whenever I make additional pushes, my PR will automatically be updated. Okay, so that's one thing. All right, so there's our basic cloning, committing, and then pushing the changes. What about the targets? Let me bring that up again. Now, again, you don't have to necessarily understand everything that's going on with the CMake list text file, but a couple of things you do want to kind of get a hold of and understand. These different targets I keep talking about are basically different programs or executables that I can build with a various set of files. So for example, I always have something that is the name of the project, like Lab 1, Lab 2, Lab 3, whatever. And then I call that the main target. And the reason I call that the main target is because it's built with the source files identified here in the main files variable. And so here you see that right now just one file is by default involved in the main target. Similarly, my project demo target, lab n, lab 0, lab 3, whatever, demo would be built using the demo files that I have listed in this environment variable set. And in this case, it's demo.cbp. And then the other target is the test target. And again, what I have here are, but a demo for the demo target, a main CPP for the main target, and as it turns out, here is the basic foundation for my Google unit tests. All right, and so this is what would be executed on the test target. All right, and so there's nothing really to test. I have a bunch of tests in here really so that I can kind of do some cutting and pasting to get started on writing my own unit tests. But this disabled flag or prefix here means that these tests will be disabled. So we won't see them actually getting executed, but we can still see the targets happening. So how do I do that? This button here on the left panel here comes up when you do load a CMake project. And if I click on that, this is how I get to my different targets. So, for example, I have my main target here, Lab N, or Lab N Demo, or Lab N Test. And I can right-click or just click on that and build that target. So now it's building the main target. And I can also right-click on it and choose Debug or Run in Terminal. Debug will allow me to set breakpoints in the code and trace through it. Run in the terminal would just let me execute the program right in the terminal window. So let me just run this really quickly. And there you go, you see the hello main. Like I said, if I wanted to debug this and see what's going on, I could set a breakpoint in here by clicking on it just to the left of the line number. And now if I choose debug, this will invoke the debugger. And you see that I've stopped here, I've paused on the line that I selected. And again, you can do all kinds of things here by taking a look at various variables. See the call stack. There are no local variables here really to look at, so there's not much to show, but again, I can just now step through this or step over statements and be done with this by just clicking continue. And that's how I can debug my programs in Visual Studio Code, which is also a very nice, handy feature as well. And that's about it. That's as easy as it comes, just like in C-Line. I can run my demo target. If I didn't build it yet, it will build it first. Has to, right? And here you see that doesn't look right. I just want to run that one more time. Hello demo, there we go. There, I see it now. And then finally, like I said, I can run my test target in the same way. And this is usually when I provide the Google unit test for you. Is a good way to see the kind of grade you might be getting on your assignment. By the way, if you try to do this and you get some errors, that most likely has to do initially with that pedantic flag being in there now, and that's why I've removed it and why this is going forward. And basically what this is doing is this is downloading Google Test and building it locally for this particular project. It's ended with an exit code 0, so it's built successfully. So now I can try to run it in the terminal, for example. And essentially what you see here is that there were 0 tests. I've got 2 disabled tests. But here's the thing at the very bottom. It'll print out the number of points you've earned and the possible points you can earn. And basically use that as a fraction to assemble your correctness points for the project. And that's about it. So if you feel like you're more comfortable using Visual Studio Code as opposed to C-Line, or you're having trouble configuring C-Line, by all means use what you are most comfortable with.